With a diameter of nearly 140,000 kilometers, Jupiter is the undisputed king of our planetary system. Its colossal size is hard to imagine. Earth could theoretically fit inside it more than 1,300 times. It is not just a giant in terms of size, but also in mass. Jupiter is about 2.5 times more massive than all the other planets in the solar system combined. This extraordinary mass makes it one of the most influential objects in the gravitational structure of our planetary system. Despite its size, Jupiter is surprisingly fast. It takes less than 10 hours to complete a rotation on its axis. This rapid rotation is responsible for its slightly flattened shape at the poles and bulging at the equator. Moreover, the rotation speed contributes to the formation of its characteristic atmospheric bands, visible even through an amateur telescope. Behind the allure of its striped appearance lies a turbulent world. Jupiter is characterized by a complex atmosphere dominated by storms and incredibly powerful winds. Its atmosphere is primarily composed of hydrogen and helium, with traces of methane, ammonia, and water, which create its iconic light and dark bands. The most famous of its storms is undoubtedly the Great Red Spot, a massive anticyclone that has been raging for at least 400 years. This formation is so large that it could contain 2 or 3 planets the size of Earth. Winds in the Great Red Spot reach impressive speeds of up to 680 km/h, making it a unique phenomenon in the solar system. However, in recent decades, the spot has been shrinking. From a diameter of about 40,000 kilometers in the 1980s, it now measures just over 16,500 kilometers. Scientists continue to study its causes and wonder if this extraordinary phenomenon will one day disappear completely. According to scientists, Jupiter is the oldest planet in the solar system. Recent studies conducted by the University of Münster estimated its age by analyzing meteorites, as Jupiter lacks a solid surface for direct sampling. It was discovered that the planet reached a mass 20 times that of Earth in less than 1,000,000 years after the solar system formed, completing its development in roughly another 3 million years. In comparison, Earth took a full 100 million years to complete its formation process. Jupiter, formed primarily from the gas and dust left over from the Sun's birth, was one of the first objects to solidify, around 4.6 billion years ago. This rapid and violent process shaped not only the gas giant, but also the orbits and structure of nearby planets. With a mass 318 times that of Earth, Jupiter exerts a powerful gravitational influence. This force has been crucial in shaping the solar system as we know it today. In many cases, the gas giant has acted as a natural shield, deflecting comets and asteroids that might otherwise have collided with Earth. Its gravity attracts and captures many of these objects, as demonstrated by the collision of Comet Shoemaker-Levy 9 in 1994, which generated massive explosions visible from Earth. However, Jupiter can also play a destructive role. Its powerful gravity can destabilize the orbits of smaller objects, pushing them into the inner solar system or out of the planetary system entirely. Scientists hypothesize that during the early stages of its formation, Jupiter may have migrated toward the inner solar system, causing gravitational chaos. This event could have contributed to the formation of the inner rocky planets, including Earth, by redistributing large amounts of planetary material. The Great Red Spot is undoubtedly one of Jupiter's most fascinating phenomena. This enormous cyclone was first observed in the 17th century, but its origins and behavior remain partly mysterious. One hypothesis suggests that its red color is due to chemical reactions caused by sunlight interacting with molecules in its upper clouds. Other studies suggest that the Great Red Spot may be fueled by thermal energy from within the planet. Despite its progressive shrinking, the cyclone continues to be an object of study for researchers, who constantly monitor its evolution using telescopes and space probes. The main question is whether this titanic storm, which has become a symbol of Jupiter, will one day disappear. Jupiter is not just a giant planet. It is also the center of a complex system of natural satellites. With at least 95 known moons, including the 4 Galilean moons, Io, Europa, Ganymede, and Callisto, it represents a true miniature planetary system. Each of these moons has unique characteristics. Io is the most volcanically active body in the solar system, while Europa is covered by a thick crust of ice beneath which lies an ocean of liquid water. This ocean could harbor life, making Europa one of the primary targets of future space missions. Ganymede, the largest moon in the solar system, is the only satellite with its own magnetic field, while Callisto has an ancient, cratered surface that could provide clues about the history of the solar system. These worlds, so different from one another, continue to fuel the imagination of scientists. Jupiter remains a focal point of scientific exploration. NASA's Juno probe, in orbit around the planet since 2016, has provided unprecedented data on its composition, magnetic field, and atmosphere. In 2023, the European Space Agency, ESA, launched the JUICE, Jupiter Icy Moons Explorer mission, which will reach Jupiter in 2031 to study its icy moons, particularly Europa, Ganymede, and Callisto. These missions are essential to answering crucial questions. How did Jupiter form? What secrets lie beneath the surface of its moons? And most importantly, are there conditions for life beyond Earth? Jupiter is much more than a gas giant. It is a key player in the history of our solar system. With its immense mass, fascinating storms, and diverse moon system, it continues to amaze scientists and captivate the public's imagination. Future explorations promise to uncover new secrets about this cosmic colossus, reminding us of how vast and complex the universe around us truly is. Jupiter is not just a planet. It is a natural laboratory that helps us understand the origins and evolution of the solar system. Its powerful gravity has not only shaped the orbits of other celestial bodies, but has also acted as a shield, protecting the inner planets from the dangerous impacts of comets and asteroids. Thank you for watching. Leave a like, subscribe to the channel, and hit the notification bell so you don't miss the next videos.